In this assignment, in the initial task, we specify the names of input and output files and specify which columns in the data frame should be removed. And then after, we use the commands to remove URLs and take out all the symbols and change all the caps to lowercase. And then after, we use the commands that input data and take away the empty columns and eliminate the clutter from the text in each column and to take out the columns that are not necessary for the report and to create a CSV file with the sanitized information. And after the completion of the initial task, then we move on to the base task, like which is task 1. And here we need to install pymongo, nltk and textblob. And here we use the functions like get keywords, get named entities, get topic, get sentiment. And here the program establishes a connection to the MongoDB database and proceeds to retrieve the data set of tweets. Subsequently, the program proceeds to iterate over every tweet and extract the keywords named entities, topic, and sentiment by utilizing the corresponding functions. The information that has been extracted is subsequently stored in a newly created name or value pair and subsequently updated within the MongoDB database for every individual tweet. In order to utilize this program, it is imperative to ensure that the dependencies have been installed and requested NLTK and corporate have been downloaded. And then we move on to the task 2. In the task 2, the employed methodology of the program involves the utilization of MapReduce in order to compute the frequency of individual words present within the textual content of the tweets. Here we use the mapper. The mapper function accepts two arguments, namely self and the input line. And here we extract the words from the input line and emit each word as key value pair. And then we use the function reducer. The function reducer accepts a pair of arguments and this is the output of task 2. And here we enter into the task 3. And in the task 3, the software application process a collection of Twitter posts represented in JSON format and discloses the geographical location of origin for each individual post. And in the function mapper, we retrieve the process each tweet entity from the input file. And in this, we read tweet object and then extract the city of origin and then intermediate key value and then we emit tweets in sorted order. And then we enter into the function reducer reducer that obtain the key value pairs that are emitted by the mapper function. And here we receive key value pairs and then after we sum up the values for each city and then we emit key value pair with the city total number of tweets and then we get the output. And here we enter into the task 4. In the task 4, the objective is to employ the MapReduce technique to arrange the dataset of 10,000 tweets in accordance with their representative tweet IDs. And in the mapper function, we read each line in the input file, split each line using comma delimiter to extract Twitter ID and Twitter content. And here we read the line from the input file, sum up values for each city, emit the tweet ID and tweet text, and then we enter the reduce function, collect all the tweets that have the same tweet ID, sort the tweets by tweet ID, emit each sorted tweet as the value with no key. To compare the performance of MapReduce with a program that utilizes MedSort for sorting tweets by their ID, we can use a standard sorting algorithm. And this is the output of task 4. And here we enter into the task 5. And ultimately, the TF-IDF approach was employed to arrange the keywords in a specific order, resulting in the retrieval of the highest n keywords alongside their corresponding TF-IDF scores. Additionally, the output was stored in a CSV file. And here, the program was designed using Dask and Python. We used Dask data frame and Dask DAG to work with large data sets. We also used the NLTK package to process the text, tokenize words, and identify parts of speech. We used the math package to calculate the algorithms. And here, the software successfully extracted keywords from the text of every tweet, computed the TF-IDF score for each keyword, and presented the highest end keywords along with their corresponding TF-IDF scores. The software successfully managed a substantial corpus of tweets and demonstrated proficient output capabilities. The output was pursued in a CSV file for subsequent examination, and I had taken some of the references from the online and from the books, and that's helped me to complete this assignment in a successful way. And